Let's work through a word problem where we have to calculate the net change. So here's a scenario. A small town has a population of 1,000 in the year 1950. Suppose the population increases at a rate given by p prime of t equals 40 times 1 plus 0.5 square root of t, where t is years since 1950. What is the increase in population between the years 1950 and 2000? Okay, so first let's think about what we're trying to find here, and then maybe try to represent that in terms of the variables and functions we're given in the problem. So the last sentence here asks, what is the increase in population between the years 1950 and 2000? So then what we're looking for is the population in 2000 minus the population in 1950, right? That'll give us the increase in population between those years. But how do we represent that in terms of our functions and our variables? Okay, well, we're given p prime of t, which is the rate of change of the population, right? So p represents the population. And then we're told t is years since 1950. Okay, so then if I were to kind of translate this into a mathematical representation, the population in 2000 would be p of 50, right? Because 2000 is 50 years from 1950, so the population at t equals 50, minus the population at 0 at 1950, which is our starting point. So this is what I'm trying to find, p of 50 minus p of 0. Well, hopefully you just read about the formula for net change, right? We're looking for the net change, and we're given the derivative of the quantity, p prime of t. Okay, so the general, let me write over here, the general formula for net change for some quantity q is the integral over whatever interval of q prime of t. Okay, so we're going to use that formula, but of course our variable is population, p. So then this should equal the integral from 0 to 50 of p prime of t dt. So if I plug in my function, then that's the integral from 0 to 50 of 40 times 1 plus 0.5 square root of t dt. Okay, so let's actually compute that integral. So I can pull this 40 out front, or I can distribute it. It doesn't really matter. I guess I'll distribute it. So inside the integral now I'm going to have 40 plus 20 square root of t, but I'm going to write that as t to the 1/2 power. Okay, and then I want to find an antiderivative of that. So if I take the antiderivative, that's going to get me 40t plus, okay, the 20 is a constant multiple, so it can kind of just hang out, 20t, and I'm going to add 1 to the power, so that's going to become 3/2 over 3/2. And I'm going to evaluate that from 0 to 50. Okay, so if I clean that up a little, that's 40t plus, I'm dividing by a fraction, which is the same as multiplying by the reciprocal. So this is really 40/3 t to the 3/2. And now I can plug in my values. So I start by plugging in 50. Okay, so 40 times 50 plus 40/3 times 50 to the 3/2 minus, and then I plug in 0, but that's just going to get me 0 because of those t's. So I just have this expression, and if you put this into your calculator, you should get about 6,714.05. So as our final answer then, we could say the population increase is about 6,714. And that will be our final answer. Okay, so this is how you approach a net change word problem.